Okay, I think we'll start. I see a lot of unfamiliar names for me, a few familiar ones, so I'm glad you could join us today. Um, so we're glad you could join us today for our FME Bootcamp. I hope you can take a virtual seat. We're in Montreal currently, so it's actually pretty cloudy outside. I'm not sure where you're coming from, but don't hesitate to let us know maybe in the chat where you're coming from. It's been a while since we've been able to give this kind of webinar at Consortech, so we're really excited that you could join us today. So just to start off, this bootcamp is a 90-minute bootcamp where you'll be able to obtain real skills and immediate value to help you integrate, automate, and trust your data. So just to go on with the presenters, my name's Maddie. I'm a GIS consultant at Consortech. I've been here for 3 years. I'll be presenting the introduction of the bootcamp, and I'll also be doing the moderation for today's discussion. And I'm also joined by Matthieu, who is a data integration consultant, who you can see currently in the video. He'll be doing the more technical aspects of the bootcamp and also the live demo. And we also have Carl, who is our senior programmer analyst behind the scenes, who's going to be answering questions. So I'm not sure if he'll turn on his camera, but he's going to be there to help you out in the Q&A portion if you need help. All right. So for our agenda today, what we'll be covering, so we have a couple bootcamp guidelines just to help you out with the platform, and then we'll go into more of the introduction part, so why we want to integrate data, and also what is FME, and then Matthieu will do the live demo, AI Assist, Data Virtualization, and MCP. All right, so for the bootcamp guidelines, so this is a 90-minute bootcamp. There is a Q&A session throughout the discussion today, so feel free to ask questions in the Q&A portion on the left panel of the Zoho platform. Feedback is always welcome. There is a survey at the end of this, so if you want to let us know how we did or any other maybe subjects you would like for us to talk about, we can do that as well. For the Zoho platform, it's an interactive platform. I think maybe it's unfamiliar for a lot of you, but there is immediate reactivity, so any message that you put in the Q&A will be answered. You don't need any software. This is not a hands-on workshop. It's really just a demo. And then also for the recording and the material, there will be material and the recording sent out by email after the workshop, so either today or tomorrow. But yeah, you don't have to worry if you want to look at more in specifics of what Matthieu developed, then you'll be able to get that by email later on. All right. So just in terms of the platform, just to let you know, there are a couple tabs in the left panel. So as you can see, there's a left panel where you can ask questions in the Q&A portion. Either Carl or someone else will answer those questions. There is also at the bottom a little emoji where you'll be able to interact with us. So let us know if we're doing good, if you like what we're presenting. Unfortunately, we won't be able to take raised hands today, so just an FYI on that. If you're having network issues, if you click on the 3 dots at the bottom, you can stop the incoming video if you just want to hear our voices. So that way maybe the network will be a little bit better. And there's also other network settings that you can play with if you're having issues as well. It's a good idea to close your tabs maybe if you are having issues for quality and all that stuff. And also a big suggestion when Matthieu is going to be doing his live demo, you can close the left panel. It'll make the screen that he's showing bigger. So it'll be helpful for you guys. So yeah, I hope the platform is working well. I'll continue on that. So in terms of Consortech, I don't know if you've ever heard about us. Some of you are maybe current clients of us, maybe future clients, who knows. Consortech was founded in 1989 and is dedicated to geospatial performance ever since. We've been a partner of Safe Software since 1999, and we're specialized in the resale and support of FME products. So our main goal is to turn disconnected data into a strategic asset. We want to help organizations connect their geospatial and business systems to be able to integrate disparate systems and data sources, accelerate digital initiatives, and also orchestrate data flows and operational process. So that gives you a little bit of a description of who we are and what we do. So I have a little poll question. I forgot we're going to have poll questions throughout, a few of them. So I have a little one coming up that I'm going to be sending out. I'd like to know, what are the biggest data related challenges your organization is currently facing? Okay, I'll start the poll. So maybe you can answer. It's a multiple choice, so you can choose a couple if you want, and then I'll publish the result once we receive everything. So you should be able to see it. Yeah, I see some votes are coming in, so that's good. All right. So I see that a couple of the results are very common. A lot of manual and inefficient processes, data interoperability and incompatibility, siloed data, data quality. I see that those are very common. I'll let you guys answer a little bit more, and then I'll close that. Okay. So I'll publish the results for you. Okay. So you should be able to see the results. Overall, the results are pretty similar in all categories. This is kind of what we see in the organizations that we work with. So as you can see, you guys are experiencing challenges that other organizations are facing. Challenges that could be multiple data formats that create a little bit of a complexity in data management and standardization. You also have large data volumes that are like resource intensive to store, manage, or process data. Redundant manual tasks, that's a big one, 43% of those. That lead to inefficiencies and increased operational costs. Data incompatibility and interoperability, 39% of your results across different systems and platforms. Also, maybe data passing through multiple stakeholders, which causes like man-made errors and requires repeated validation processes to be put in place. And then another one would be limited ability to process and analyze geospatial data. That's also a big one, along with other data sets in an integrated manner. So these are a lot of the challenges that organizations are facing. You guys are living them currently. So this is why we want to do this bootcamp, just to kind of show you what could be done, what you could put in place to help kind of solve these issues. So this is why data integration matters and is essential. With data integration, we want to allow data to communicate by breaking silos so that it becomes less isolated and more accessible. We want to render trusted data accessible to internal clients, like other departments that you have in your organization, or external clients that may need the information. We also want to ensure faster decision making for people in positions of authority, or like in case of emergency, let's say having an interactive map with a ton of different essential services is best in case of emergency for municipalities, for example. You want to be able to allocate resources on more complex projects as well by reducing manual or repetitive tasks, and so automation can help with that, and also increase data quality and consistency by removing standards, man-made errors and sensitive information. So in terms of all this, these are all goals that we have with data integration, and this is where FME can come in and help you out to implement basically those goals. So FME is an enterprise integration platform. You may be familiar with it or not. So obviously we resell the product and we provide support for FME since we are a partner with Safe Software. So FME is basically an orchestrating platform, or most commonly known as an ETL. If you're not familiar with those, it's extracting, transforming, and loading the data. So it processes requests and communicates the information to the server or to clients according to maybe organizational standards. So it'll allow the process of information. So it sits as a layer between data sources and the end users. It's the only ETL that allows for deep spatial integration on the market. And in terms of products, there are a couple in the FME umbrella. So FME Form is a visual platform that allows you to create low code, easily maintainable workflows and transform the data using one of the 500 transformers that they have in the software. And then there is also FME Flow and FME Flow hosted. FME Flow is used to automate workflows through triggered events like automations like triggered events, schedules, or making self-serve options of the workflows to different users. FME Flow hosted is the cloud version of FME Flow, which is basically going to be hosted on the Amazon Web Services by Safe. And then you also have a recent product, which is FME Realize, which is basically the augmented reality platform of FME. It's compatible with iOS products, and it allows users to visualize, update, and interact with digital trends in the real world. So that's kind of a global understanding of all the FME products that exist currently. So if we go on to talk about supported formats, it started off in the late 1990s with GIS and CAD, and it kind of expanded through like 3D, IoT, BI, and things like that. And now we've gotten to a point where we can integrate generative AI, augmented reality, cloud native products. So there's over 400 formats of data standards and applications that are supported by FME with the 500 transformers that will help you transform and integrate that data. So there are a big number of formats that are supported in FME, and that's kind of the power of it. So I have another poll question that I would like to ask, and that one is, which category of enterprise systems does your organization primarily work with? So I will start this poll, and you can go on ahead and vote, and then I'll publish the result. You have a choice between GIS and spatial systems, which is very common, enterprise resource planning, asset and operations management, or permitting data and enterprise systems. So I'm interested to see, I see that a lot of people are working in GIS, which I'm not shocked about. And then a couple people working with asset management products. Okay. Okay, so I'll post the results in a couple seconds, but it's actually pretty astounding. I wasn't expecting all this. I'll publish it right now. So 95% of you are working with GIS and spatial systems. Also a little bit of asset and operations management, permitting, and data enterprise systems. I'm not too shocked about that. But very good results. Obviously, we're going to be talking about what systems integrate with FME. So if we continue on this, and thank you for sharing, as you can see, FME is able to connect to a lot of different systems. There is no limit really to what FME can do. In terms of asset management, FME is commonly used in our projects to extract and synchronize data such as like fleet or infrastructure data sets from platforms like maybe Geotab, for example, and connect them to enterprise asset management systems. So that could be PST Citywide, CityWorks, IBM Maximo, IBM Tririga, Trimble Unity. So these integrations ensure that asset data is always consistent across inspection tools, operational systems, and planning platforms. So FME also plays a key role in connecting to core database environments. We frequently integrate with SQL Server, PostgreSQL, PostGIS, Oracle databases, and we also can process and extract data from Microsoft SharePoint for document management, or Amanda for permits. So this allows us to automate workflows like extracting information from documents, validating data, and loading it into structured systems. And on the business systems side, FME integrates with major ERPs and enterprise platforms like SAP, Oracle, JD Edwards, and ERP, Microsoft Dynamics 365, Salesforce, you see a couple of those in there, Marvel. So these integrations help connect financial, operational, and customer data with spatial and asset data, eliminating silos across the organization. And last but not least, obviously you guys are working a lot with GIS and spatial systems. As an Esri partner, GIS is at the core of most of the integrations that we deliver. So we commonly connect with FME with ArcGIS Online, ArcGIS Enterprise, ArcGIS Utility Network. So this enables organizations to centralize spatial data and use it as a foundation for decision-making, across all departments. So as long as your system has a structured API documentation, database credentials, or files, is a SaaS, or can connect through a network file, FME is going to be able to connect to that system. It was built with the purpose of being able to connect to any data and any AI, so there is really no limit to what FME can do. So on to a next poll question. I'll go back to my list here. I'd like to know which industry you work in. Obviously, we have some expertise in a lot of different industries, but I'll just start the poll here. And I guess we'll see what kind of results. I already have an idea of what the results will be, mostly local state, but I'm interested to see if there's other different industries that are in the conversation with us today. Okay. So 70% of you almost working in government. I'm curious to know what the others are. So if you want to put that in the Q&A, that would be really nice. A little bit in utilities, a little bit in software. I'll publish the result right now. Oops. All right, so a lot of local, state, federal government. I'm not too shocked about that. I think that's what we saw in the attendees list. So I'm glad that you can join us. And also utilities, a little bit. I think 1% transportation, Department of Transportation, airports, some in software editors. I'm curious to know what the others are. If you want to share, feel free to do that. So as you can see, there's a lot of industries that have joined us today, and our expertise covers a lot of different industry. So I'll keep on going. But over the years, we built expertise with the industries that you can see on this slide. So a number of our clients are local, state, or federal governments or utility companies across North America. So our project variety is very wide. Common projects for these industries are GIS asset management synchronization projects, where we can automate synchronization, for example, between inspection, maintenance activities, and GIS assets to improve capital planning and reduce outdated information, integrating to enterprise asset management softwares. We've also recently built a workflow to digitize historical and paper work order reports that are extracted from Flowworks using AI for a major Canadian city's waters department. And then for transportation, utilities, and local governments, we support on a number of different projects, such as working on improving accuracy of data sets for conflating and integrating CAD and GIS systems to ensure accurate infrastructure data for operations and emergency responses. We've also worked in doing a little bit of indoor mapping for airports throughout Canada. So that kind of covers our industry expertise. And then obviously we support software editors who serve these industries. So if you are a software editor and you're interested in working with us, we are definitely interested in working with you. So our expertise ranges on multiple different projects integrating with EAM, ERP, database, and spatial systems. So now that we've covered the basics, I'll hand it over to Matthieu for our live demo. So Matthieu, if you want to share your screen, I'll turn my camera off.
All right. Thank you, Maddie. Great introduction. So Maddie mentioned there were a couple of things that I was going to talk about today, mainly the AI Assist and then the new-ish tools developed by Safe Software, so data virtualization and MCP servers. I'm going to start right off with the AI Assist. So it's just going to be mainly a quick glance over the functionality. I'm not going to go too deeply into the whole thing. So I'm going to start by sharing my screen here. So I hope you guys can see well on what's happening here. So I don't exactly know what level of expertise you guys have with FME, the FME software suite, but like just to do a quick tour of what's going on here, Maddie mentioned FME is a low to no code interface from which we can read, transform, and write data in pretty much any format that you can think of. Here, this is the main window in which you are going to be working when using FME Workbench, FME Form. Very quickly to tell you guys how this works. So these components here on the canvas are the things that are components of my workflow. In orange here, you have where I read the data. So in this case, I'm reading a business owner's list from an Excel file. You can see it's very easy to drag things around, drag and drop and everything. So this is where the no code and like this part of the software comes in strong. Then in the blue here, we have all the transformers. So what's happening here is I rename things, I remove things, and then I reproject from a coordinate system to another. So again, very simple. You can very easily see the flow of the workflow within your project here. And then at the end, after I've decided to do all of these transformations here, I can write everything down in a file geodatabase. So here it's completely seamless. There's no other operation. I just read from Excel, I write into file geodatabase, and things are completely smooth. I don't need to do any extra information, any extra operation about changing formats, doing anything like that. This just works like this. So just to show you guys, I can run this workspace here by pressing the run button here. And you can see here it's running on the computer. It's for some reason very slow, specifically on the day of the bootcamp, so that's perfect as per expected. Here I can see what the data looks like at any step of the process. So just to show you very briefly, I have these columns of data here for like first name, last name, company, all of those things. And here I can see at any step of the data how the data changed. You can see here definitely that like with the attribute remover here, I went from 6 columns here to 4 because I removed the 2 last columns here. Anyways, so this is how at a glance an FME Workbench, a project in FME Workbench works. You read the data, you transform it, and then you write it somewhere else. Now to talk about the main point for today is the AI Assist. So here in this version of FME, there's a button up here that I can click on, the AI Assist. And here it's going to bring me this little window here asking questions about what do I want to do with my workspace. So this is great. On top of what I can write, you can see here that there's this little text here, context-based on entire workspace. It means that anytime I'm going to ask the model, the AI agent, a question, it's going to take into consideration the entirety of what's happening within my workspace. So Here, I can ask it, what is the purpose of this workspace? Because in this case here, this workspace has been extremely poorly documented. There's no annotation, there's no bookmark, there's nothing. It's a terrible job. I don't know who made that, but it's awful. So I need to ask the AI what's going on with this workspace. So here, I have this little like workspace summary. This workspace loads the business owner worksheet table from my Microsoft Excel files, renames stuff, removes stuff, reproject stuff, and write the result into a business owner feature in an Esri file geodatabase. So that's great. It understood everything. Now I know what's going on, and it read perfectly every information from all of my transformers, readers, and writers within the canvas. And now we see, so this was context-based on the entire workspace, but I can also just click on one single transformer somewhere on the canvas. And here you can see context, one currently selected. So now it means that when I'm going to make a request and query my AI agent, it's going to just take the reprojector as a context for the query. So if I say, what does this transformer do? It's going to reply to this question knowing that the context is this reprojector here. So like it's going to know which transformer I'm talking about. And here I have the detailed response specifically for this transformer. The other nice thing is anytime you ask a question about anything going on in a workspace, it's also giving you the link to the documentation. And when you click on it, you have access directly to the documentation specifically for this transformer. So you can have all the actual information from the official safe software documentation for this specific transformer. So there's that. The very nice thing about it is like, one, you can ask questions to understand how a workspace works, but you can also ask questions to get ideas to start being creative, and also to just, if you're feeling stuck in how you want to build your workflow, you can also ask the AI to maybe give you pointers on where to go. It's an AI that's linked directly to all the FMEs and safe software documentation. So it's going to give you way more precise answers than if you're going to try to go look on like Google, and if you're going to ask like a generic AI model like ChatGPT, Claude, that don't have access directly and are not linked to this documentation and like the FME knowledge base from here. So it's a very powerful tool. Keep in mind though, as usual, this is an AI, so it can make mistakes. It's always nice to still double check when it's offering solutions and stuff, just to make sure that you're not gonna go somewhere you don't want to go with this. So this was just a quick glance at the AI assist. I'm gonna stop now for this pointer here. Obviously, a lot more possibilities, but it's we don't have all the time today to talk about everything that's possible with it. So I'm just gonna stop sharing this for now. And I'm gonna try to give for the next things, I'm gonna try to give a bit of context for the next pieces of content I'm gonna show you guys. So here, we're going to pretend we're a municipality. So in this case, I chose the city of Toronto. And we would like to make our public data more easily accessible and for everyone. So developers, decision-making people, or simply citizens of Toronto or citizens of anywhere else, actually. Just as a PSA, I'm not affiliated with the city of Toronto in any way. I just thought it was a nice example to have public open data to give context for this work. This still a bootcamp. So to make our public data more easily accessible, we have different solutions. And through versions 2025.1 to 2026.2, FME has brought two different ways of doing this. So mainly through data virtualization in 2025 and MCP servers in 2026. So I'm going to start a little presentation here. Perfect. So here we are. With FME's data virtualization, it provides a flexible, no-code platform for connecting all your data, applications, and AI systems through the use of APIs. It brings the benefits of integration, automation, and governance together. And with data virtualization, you can achieve faster decision-making because you have instant access to live data. You also have lower operational costs because you're streaming data directly from the source. Better governance and security, thanks to FME's authentication user and role system, is directly tied to this FME security system, and also higher productivity because it's, again, a no-code environment. So anyone can build their own API and they don't need any previous knowledge of how it works to build one. So when do you want to use data virtualization? You can use it when you need to connect systems, when you want to automate workflows, when you want to provide consistent real-time access to information. It's ideal for organizations looking to modernize data sharing without replacing existing systems or building custom middleware that's super annoying to maintain and just build in general. In our case, for the context of this bootcamp, we would like to deliver live, standardized public data to either internal applications, dashboards, or even a public portal. Even to share it across departments or organizations, usually data virtualization is the right tool for that. So how does it work? It acts essentially as a bridge between your data and the systems that need it. Each API you build in FME Flow, so again, FME Flow, this web platform that Maddie talked about just before, each API you build there, it connects directly to one or more FME workspace, which will handle the data access, transformation, and delivery. So when someone makes a request to the API, FME Flow will run the connected workspaces in real time, process the data, and then return the result in the requested format. So it means that your APIs always serve up-to-date information. There's no need to export, synchronize, maintain separate copies of data. The other very nice thing about this is that FME Flow automatically documents every API using the Open API standards, and it provides an integrated Swagger interface for testing, sharing, and exploration. So in our case, I will show you directly. Quit this presentation here, and I will show you directly this interface that I'm talking about. If I can get it out somewhere, it's here. Perfect. I'm going to share my screen again. Sorry for a little back and forths. It's a bit of a hassle. Here it is. There it is. So you guys can see well. It looks like you can. Perfect. So here, for the context of this bootcamp, I have built a very simple API, and there's two different endpoints here. We have the about endpoint and the energy consumption endpoint. So again, I'm going to assume you guys are familiar with the generic Open API way of doing also Swagger documentation and everything. So name of the API, quick description to know what we're talking about, and then the description of all the endpoints. So you have, for the purpose of this bootcamp, I created two different endpoints from the same API. Just the general one, which returns general information about the Toronto Open Data API. So this one has no parameters. You can just try it out, execute it with nothing. Oh, and I actually need to connect to, because it's authenticated. See, it's inheriting the credentials from FME. So I just needed to get a token to be able to access this. Execute. And I've executed it here, and I got this response. So it's a very simple JSON, hard-coded JSON file that's giving me name, website, email, department focus, and all stuff like that. I don't know if you can see well enough, but I'm going to zoom in a bit. So a very simple endpoint. This one does not require a workspace in the background. It's just a hard-coded response to this specific about call that we have here. The second one here that I've built is essentially retrieving energy consumption, electricity, natural gas, are both data, geographical and general information about city-operated buildings. So this is directly pulled from diverse sources within the Toronto Open Data database. This one, on the other hand, has parameters. So when you want to try it out, you can decide to limit the number of results returned by the query. You can also filter by postal code if you want to. So for instance, if I want to have just from this part of town, I can select this, and I can also filter by a year for the records. So if I want to filter for just the year 2024, this is what I can do. And then I can execute my call, wait a bit, and here I get this response body containing all the data I want with property type, property name, year, electricity consumption, coordinates, and everything for further treatment. So this is what the documentation looks like. And now I'm going to show you guys how to make all of this, and not to make all of this, but what it looks like on FME Flow interface. So again, I don't exactly know how familiar you are with this interface here, but this is our main interface for FME Flow. And you can see on the tabs on the left, you have access to this data virtualization tab here. So this is the one that I created for you for this bootcamp today, the Toronto Open Data API. So I can click on it. And here I can see multiple tabs appearing again. We can check the details. So this is giving a quick summary and description. It's essentially the same that the one we have on the Swagger documentation here. And a few other options that we're not going to take a look at. The important ones are the security, because as I told you before, the very nice thing is it can be tied to the security configuration of FME Flow, which means that if you have users and roles, you can make your endpoint authenticated, which is what I did for the purpose of this bootcamp, which means then you have roles and users that you can allow specifically for the use of your API. Obviously, in our case, it would be better to make this unauthenticated because it's, to retrieve public data. So like if people want to have access, any citizen wants to have access to this data, it would be better to put it like this. I didn't do it, again, for the purpose of this bootcamp. But yeah, you can just inherit all the security roles for your endpoints and then manually change them for every endpoint too. So the access level, I can change this one to unauthenticated if I want to manually instead of changing all of the endpoints specifically. In the first tab here, this is where we get our endpoints. So again, I can go back on the about and energy consumption. When I click on about here, we have the path, and this is all informations that we are going to find again on the documentation. And then this one didn't have any parameters, so that checks out. And the response here is just a manual response. We don't need to use a workspace here, so manual response. And I just decided to write this bunch of text here, which is the text that we got in our response before. On the other hand, we have the other one, the energy consumption here, that is parameterized. So you recognize the parameters that I used before. So the limit, the postal code, and the year. So, and the description that they have in the Swagger documentation as well. And then the response. So here the response is tied to a workspace, and you can design multiple response codes with the status codes. So the classic OK one with 200 when the response is correct and you get the actual content response that you want. 204 in case there's no content and say for the parameters that you gave, no data was found. Well, it's going to return this error here. And bad request in case the parameters were incorrectly formatted or something was wrong within the request. Obviously, those don't exist naturally. You have to create them manually. So your API is complete and can answer to any type of request in a best way. So here we see that this one is linked to a specific workspace. So we can check in the workspaces here tab, and we have this workspace here that's been assigned and it's shown here. So this is the one workspace that you can find that's going to treat your request for the specific API call. I'm going to very quickly show what it looks like. So my deepest apologies for everyone who's not super familiar with FME, because it's going to get a bit more confusing. I'm just going to try to be as quick as I can and try to be as surface level as I can. But you recognize, again, the same patterns as what we had before. We have this orange thing here to read the data from somewhere, and then the orange thing to write it somewhere. So in a very simplified way, this is still how it works, and we have still like all these transformations happening here. I'm going to zoom in a bit so you don't have to blind yourselves trying to see what's going on. But essentially, I've organized things with bookmarks. When the request is received through this orange part here, this reader here, I do some sort of cleanup of the parameters and also create my request for the data that I'm going to try to fetch through my call. So here I'm creating a where clause that I'm going to use in another reader here that's going to read the data with my where clause and get the energy consumption of the buildings from this thing here. Once that's done, we join it with another data, which is like essentially the addresses of Toronto, just to make sure that we also have the good coordinates. And we clean the data up and we put all of that into a JSON format and we send it inside of our writer here. All these other things here are the status code that we're creating in case something bad happens. So here, as we're cleaning up the parameters here, if anything goes wrong, well, then we go into this little transformer here that says, the parameters are not correct. And so we're creating this error code, the status code that's 400 with the error message here, and we're sending it to the writer here. Same here, if we don't get any result from our initial reading of the energy consumption data set, we're just creating this thing here. We test, did we get a response? If we didn't, same thing. We just create an error code, a status code of 204, and we send this here. So we need to manually create all of those little things to make sure the workflow is clear and everything is going on smoothly. I can just also show you a little like test run. What's going on here is when these would be the parameters that I used within the API. I'm hoping it's not too small, but you can see here the limit, the postal code, and the year. So this is essentially the same as what I had before. Running all this here and see everything is going through these little transformers here. I'm reading the data here, and I have essentially the same information as what I had before. See street address, the year, property name, and all of that. So this is very quickly how it works. And then once that's done, we're creating this little JSON thing here to create our response body. Oh, this is disgusting like that. Let me just change that. And see here, this is the JSON that we received within our Swagger documentation here at this point. Here is the exact same file that we're getting from our API call. So this is essentially how the data virtualization works. And once you create those, once you have all of your endpoints, once you have everything set up, you just have a very nice tool that makes access to data super easy and in a very centralized way. Everything is done through the FME workbench. Everything is done through these processes here, these workflows. And all your data is standardized. All your data has the right format for anyone to access it. So it can be sent to other workspaces. It can be sent to dashboards. It can be sent to other organizations. It's a very nice and unified way to transfer live data. So moving on, I'm going to go back here. Stop sharing this. Go back to the slide. Sorry, there's a lot of back and forth. I'm going to share this again. I'm going to do this. So here, for the key differentiations between making your API endpoint from FME flow rather than just creating it from scratch with coding. It's just way faster in general. Again, I built this API in a matter of like maybe 30 minutes. I had no code to write at any point. Whereas I think for like custom code or API development, it takes a lot more time, and it's like not automatically integrated in your system from the get-go. It's included in the at no extra cost in FME Flow. As long as you have an FME Flow subscription, you have access to this tool, and it's just there. For custom code or API development, high-end API development is just more development costs and also ongoing maintenance. Security, I said it before, I think it's very nice that you can directly infer your security roles and authorizations from FME flow. If everything is set up correctly, you don't have to do anything almost. Whereas, like, again, you have to do it by hand if you don't use FME flow. And for the live data access, here you saw it in my workbench. I just have a real-time access to any source. There's no duplication. I'm just looking directly in a SQLite database. I'm looking into the data directly from the Toronto Open data. There's nothing that's happening. I'm not duplicating anything. It's just directly from the source. So it's another nice thing here. My question now is, though, what if it's a very powerful tool for developers, this data virtualization thing. When they actually want to create the pipelines for data to be transformed and sent across organizations, it's very powerful. It's very nice. But the thing is, it's a tool that's developed by developers and for developers. It's still a very closed way. I don't think any decision maker is going to try to create those things or like use those things by hands. They will have to ask like the tools developed by the developers to access the data. So my question is here, what if you wanted to make your data even more accessible? What if instead of having this gated behind like an API call and there's like slightly complicated notions for someone who doesn't really use a computer very often, but you instead want to have anyone be able to query for the data they want without having to go through the hassle of making a confusing API call anywhere. Well, for this specific use case, we have, I'm going to present you the latest tool introduced in version 2026.2, which are the MCP servers. So what are MCP servers? So MCP stands for Model Context Protocol. It's a standardized bridge between AI models, so like Claude, ChatGPT, Gemini, I'm sure you guys are familiar with those, and external tools, data sources, or APIs. They allow AI agents to autonomously discover and interact with the resources through a universal interface. In our case, again, for the Bootcamp, we could connect to the same data from the Toronto Open Data website. We plug it into an MCP server and then directly query our data with natural language. The way it works, as you can see on the graph here, for every MCP server you create on FME Flow, you can create tools associated to it. Every tool is going to have its specific purpose. It's kind of the equivalent of having multiple endpoints for an API. Here you have one MCP client with multiple tools. The ones that I made for the Bootcamp is essentially the same as it serves the exact same purpose as the API endpoint about the building's energy consumption. So it's a nice parallel. But I could also create tools for, I don't know, check for public events in Toronto, or like to query for current public construction as well in the city. It's just like you create as many tools as there are topics that you want people to be able to interact with. So this is how it works here. As another side note, very quickly, you can also use MCP tools directly within an FME workspace through the MCP caller transformer. So this is a transformer just exactly as all the same that you have seen in the workbenches that I've showed you guys, except that this one just connects directly to MCP tools and MCP servers, so you can grab the data from that and connect then after to other models to interact with the data. So this is how it works for this. I'm going to show you, instead of just talking, I mean, I'm still going to be talking at least for 20 minutes. Sorry about that. But I'm going to show you guys how it works with a simple query with the MCP server that I created. And I'm going to ask Claude a question about the data that we just saw. So I'm going to stop sharing this and boot up my friend Claude in a friendly manner. Here it is. Share screen. There's a billion back and forth. Again, deepest apologies. So here I am on my little Claude desktop application. And I can see here in the little plus here that it's connected to my great Toronto Open Data MCP server. So I can ask Claude, for instance, can you give me the list of buildings in the same postal code N9V and their energy consumption for 2024? Question mark. And we ask Claude. So here we see that it's immediately going to go find my tools and then creating this nice little formatted table from the data that directly came out of the workbench associated with the MCP server. So see, we have 22, which is exactly the same as the number we had before from the API. Here we have the details of what happened during the reasoning of our friend Claude. So it went to find this specific tool here. It went to query my workspace, and you see that it understood specifically my arguments in my natural language request. It saw N9V, it saw 2024, and also added a limit, arbitrary limit here on the results not to overload the system, and then made the request and immediately transferred it to the FME workbench, and the FME workbench gave a JSON file back with all the structured data, and then Claude is giving that data back to me. So it's a very powerful way of interacting with data because you just, again, no gating behind like an API call, no gating behind anything. You can just talk to the AI and it's going to access and go find the data for you. So how do you do that, and how is it looking in the FME flow interface? So right under data virtualization, you have this little thing here, the MCP servers. As a side note, this is a beta version of FME flow. So for now, this does not exist in the current available versions that are out, but in the next 2026.2, this is going to be available for everyone. So here we have our MCP servers, again, exactly the same as the Toronto Open Data, literally the same name, except I didn't add API because it's not an API. I click here, and here you have two tabs. You have your server details. First, your URL, which is the URL you're using to link your MCP server to your AI agent. Could be Claude, Gemini, ChatGPT. You just use this here. And then you create your tools here. So tools, again, kind of the equivalent of endpoints with an API. And when I click on this one here, you have the description of the tool. So the very nice thing is, again, here, there's just one tool on the server, this one here. But the nice thing is the AI agent is autonomously navigating through the tools depending on the user's query. So it could call the same tool multiple times with different parameters, or multiple different tools for the same query. The only thing is it needs to know precisely which tool to call in what context. So I'm going to show you that. The very important thing that you guys need to, the information you need to retain about the MCPs on FME Flow is here. This description here is what's going to help the AI agent know what tool it has to call for what request. This is a very, very brief description. Most of the time, they can be way longer than that, depending on how complex the task is. But it's with and through this description here that the AI, when it's going to see the query of the user, it's through this description that it's going to know and understand, I should call this tool or that tool or both, or, and with what parameters. So you have the description, extremely important, gives all the information the AI agent needs to know if it has to call this specific tool. And then you give it a workspace that's going to treat the request. So in that case here, we saw that on the request, we had parameters here, and these parameters are found here in this parameter tab. So again, exactly the same as for the API. We have the postal code with a long, thorough description. I even gave the description a regex to make sure that the format of the postal code was going to be correct within my workspace. You have the year, so here very simple, but again, long description just to make sure that the AI knows which parameter to call in what context, and also the limit of how many entries we want back from our request. So these are all parameters that exist as well within our workspace on FME. So I'm going to show you very quickly as well how it works in the backend here. And it's in the wrong window. Perfect. Okay, sweet. This somehow somewhat looks like the one we had for the API call. We have getting the parameters, cleaning up the parameters, creating the where clause from the parameters, reading the data from our energy consumption data SQLite database, joining with the addresses, and then formatting into a JSON thing, and then writing into this MCP writer at the end. The different thing is this time, instead of having everything sent in a JSON file in our dataset, the parameters that we saw are actually parameters that you have to create in your workspace. They're actual parameters here. So we can see here we had our postal code, the year, and the limit here, and they can be found, like all of the parameters can be found here. I'm so sorry, I cannot zoom in much more. But here, yeah, postal code, year, limit. And this is where, this is the parameters that you're using for your specific request. So if I run this workspace blank without any call, it's asking me the same parameters. So I can say the same postal code, M9V 2024, limit of 100, sure, it works fine. And you send this, and see it's doing exactly the same thing. It's getting the same data here that I see, formatting in the same way. And when I check this here, this is annoying. Okay, JSON content, and yeah, I'm so sorry about that. And here we have our same JSON file that's being sent in the output of our workspace. So that's the main thing about it. So it's a very powerful tool, because here the only thing the AI had to do was interpret the request of the user and essentially send it to a workspace somewhere that's going to do all the heavy lifting in terms of filtering the data, testing the data, making sure the data is the right format, and then it's going to send it back to the AI, and the AI just going to have to interpret this data and just be like, okay, well, there's a few entries for this specific point, there's a few entries for this. Here's the energy data. I'm just going to give it back like that. Another back and forth with the presentation. I'm going to stop sharing this and go back to my presentation here. And just do this. Okay. So we'll recap, because obviously it wouldn't be that great if it was just positive points. So advantages, it's what I said before. Whereas the API and the data virtualization were super robust and super solid ways of making data accessible for any cross-platform shenanigans, it's still kind of gated behind the idea of having to make an API call. So unless you develop the tools to interpret utilize the API calls, I'm not sure your average grandma in Toronto, 85 years old, like, is going to make her API call to try to find if there's like free public events, like, you know, that weekend in Toronto. So the advantage here is anyone can have a look at your data. There's zero exposition to any computer-like tools. You just query what you want in natural language, and then in the background, it's an FME workspace that does the job. So very smooth on that. Another thing is AI agents, they can extrapolate. Even if you haven't programmed the tool for the question the user is asking, if there's like slightly off what you're asking, since it's still an LLM you're talking to, it can extrapolate from the live data that we want and create more things with it. Okay, I'm going to switch back one last time. I promise it's the last time, but I want to show you something interesting specifically regarding that. So we're back with Claude, gave me all of this, and say, if I ask the model to build me an interactive map from this data, I could have asked it from the get-go, right? I could have said, build me an interactive map of all the buildings in M9V and their energy consumption for 2024. So here, it's going to think for a little bit, obviously, but then create like an interactive map with all the data that's pulled directly from the workbench here, from the FME thing. If we don't want to wait, I did this already before. Okay, just do this maybe. Yeah, sweet. Okay. Okay. So here it's not the same chat because it's taking a bit of time to just build the map and everything. But as you can see from the same data that I grabbed from my workspace, it didn't create anything more. And I know the data is exact and correct because it's directly pulled from the Toronto Open Data thing. I have this interactive map of this postal code with every information I need about this. Gives me the energy consumption. Obviously, adding more things from the internet with like pictures and stuff, which is completely not necessary. But you know, it's AI; they just always go overboard. But yeah. Again, nice thing, the AI, they can extrapolate. And if you ask something like here, I never programmed my MCP tool to build a map, but yet I can still ask the AI and it's going to use my data, my clean data from the FME workbench as a foundation for this interactive map that it's showing right now. So this is, I think, a very nice thing that you can have with AIs is they have the flexibility of being able to create more things and go a bit beyond what's been programmed for. Whereas if it's an API and just ask the API, make me a map as a parameter, I'm sorry to tell you, but it's probably not going to end up super well. So I'm going back to my presentation. I said it fast back and forth. That's it. I'm done now. Share. And go back here. So they can extrapolate. It's very sweet. It's very nice. Other advantage, I don't know if anyone is super familiar with this, but the concept of tokens that you use for an MCP server, that you use way less token. You use a very like a much smaller context window, because with an MCP setup on FME flow, technically the LLMs, they just have access to a filtered subset of data, and we just retain full control over the background data processing pipeline. So the citizen, any user will simply need to make a natural language request, and the agent will then launch a process using the correct parameters extracted from the request. There's no internet searches, no token explosions. It's just simple queries, and the bulk of the processing is carried out by third-party software rather than by the agent themselves. So they've simply been useful. The agents have been useful in translating the query into parameters for a process to which the user has never been exposed. So that's a really nice thing. And also, you don't, it's again, it's a subset of data. So you don't have like a billion tokens used in one request because you forgot to, I don't know, clip your JSON format something. So, so that's a very nice thing. Also, a good point is, since the model theoretically doesn't need to be the most powerful one, it could be possible to host your own model, and because again, it's just used as a translation tool between natural language and the parameters for your workspaces. So you could definitely host your own model, and that would completely negate the token cost, and also maybe you would have a less remarkable environmental footprint, which is great sometimes. You also would remove a lot of drawbacks from like LLMs in general, like again, environmental footprints. And since the data is very centered about the things that you already programmed it for, no less bias, less discrimination, less all the things that happen with AI all the time. Obviously, though, it's not perfect. You always have this AI uncertainty and this black box thing, as in the AI is doing still a bit of reasoning, and sometimes it's going to extrapolate information you don't want it to extrapolate. It's going to do some math that sounds very obscure and wrong. And so here I asked for a map from the data that it had. So this is an example where it works fine. But if you ask to compare stuff, if you ask to count data, if you ask to do some math on the data, and your workspace is not doing the math itself, well, then this little window that you let the AI for interpretation and extrapolation, well, then you have no idea of how the AI is going to do the math. You have no idea of how the AI is going to do any calculations. And then it can become frustrating because you have programmed like a whole tool for something, and as soon as you ask something slightly out of it, well, the AI does it, and then you're not really sure of if the results are going to be correct anymore. So the thing you could think about to prevent this is, oh, I just have to make a tool for every request, right? Well, good luck with that, because since we're talking in natural language, any phrase, any sentence is possible. Like the user can virtually say and ask anything to the AI. So it's exponentially or impossible to just build a tool for any potential request for the users. So that's also something you have to keep in mind, because people are going to eventually ask for things that you haven't programmed your AI for, and then it can lead to wrong answers. It can lead to uncertainty. It can lead to a lot of bad things. And we do not want to create misinformation, and we don't want to create mistrust for the people that use our AI. I see that you guys are a lot working for municipalities and public institutions, well, or federal. We want people to trust us with the data that we give them, right? And specifically for public information, we do not want people to be defined and defined of what's being told to them, right? So take with a grain of salt. MCPs are very powerful, and you can see how, when properly built, they are a super, super interesting tool for a lot of various reasons. But it's just to have keep those things in mind, because it's not perfect, and it's people building these tools are aware that it's not perfect. But as you guys are going to also experiment with those, it's always good to keep in mind that it's not a perfect tool, even though it's very powerful. But I think that's going to conclude most of my presentation. I hope no one fell asleep. I'm going to hand it back over to Maddie, and thank you guys for listening. And again, if you have any questions, don't hesitate with the Q&A section. Thank you.
Thank you, Matthieu, for sharing your knowledge. We do appreciate it. I hope everyone else appreciated it. I'm just going to go back to my presentation. Unfortunately, I'm not too sure. Slide 17. Perfect. Okay, so I have a last poll before we end this. I'm going to start it, but we would like to know which of the new FME features that Matthieu presented would you be more inclined to test after this bootcamp? So I'll start the poll. That way we can know what you guys think and what you enjoyed the most. Okay, pretty good results already. Okay, so it's pretty equal on all of them, a little bit more on the AI assist. I think there was a little bit of maybe being scared of the MCP servers and confidentiality and all that. All right, I'll publish the results. I can see other people are voting, so we'll wait a couple seconds. All right, I'll publish the results. The most voted was AI assist, so that's pretty good. Data virtualization a little bit less, and then MCP server as well. So we hope you really enjoyed this presentation. I'll give a couple minutes for Q&A if you guys want to ask some questions that Matthieu can answer. I think you answered a couple ones already, Matthieu, but if you want to have ask additional questions that Matthieu can answer verbally, that would be great. So I'll give it a couple minutes. One of the questions was if you could change the symbology based on energy consumption rather than the Google rating. I'd imagine you could. You answered that, Matthieu. Oh, there's a question in. We use Microsoft Copilot. How, for example, would we make Copilot aware of any MCP server tools that we are hosting through FME? Do you know the answer for that, Matthieu?
I'm going to share my screen. I'm not exactly familiar how it is with Copilot, but I'm going to share how it is with like ChatGPT, for instance. Like any oh, yeah, I'm going to become the presenter. Yoink, yoink to your screen, Maddie. Okay. Let me show you here. Okay, it's going to be immediately not professional because it's not from the presentation anymore. But here in ChatGPT, here you have the applications here, and in the applications here you can create an application here. It's all in French, and then you create the name, its name here, and the connection here. And this is exactly what I was talking about. This is where you use the MCP link that you had in the server details here. You copy this link here and you paste it here. And here, no authentication because I don't care about authenticating for this specific part. And then you create this tool here and it's going to be available. I already created it. So it's already here, Toronto Open Data MCP. And then once you go in a chat, you can grab this here for your specific needs, and then it's going to specifically query from this tool's knowledge base before looking anywhere else. So now it's linked to ChatGPT. I'm not going to lie, I'm not super familiar with how it works with the Copilot, but I'm sure there's a lot of resources online to let you know how you can link it. But essentially, the core of the mechanic is just grabbing this link here, and immediately it's going to make your AI agent aware of where to look for the data. And here you can also change the security of MCP server. For my case, again, I haven't technically right now you could yoink this link and connect from, because I didn't authenticate anything, so you can just take this and try it for your on your own AI agent. But yeah, that's where this is all made through this link.
Someone says that Graph API has a Copilot endpoint, apparently.
Okay.
So that could be helpful. There's another question. MCP limits the LLM when sending structured queries to tools, but when the LLM sends responses back to the UI, is there still a risk of it going overboard since that part isn't constrained by MCP?
Yeah, I mean, it's what I said essentially of like, if say you want, like I asked for the public energy consumption of some buildings within Toronto, but then if I say like how many of them are there, but this is not returned by this is not explicitly returned by the workspace. So it's just a big JSON file with like, say this time there's like 158 entries. Well, then it's the LLM that has to count the amount of entries within that JSON file. And then here you're not even like, you're not sure if it's going to count correctly or not. And it's going to say a number, and you as a user will have to trust in this number. But then you can also check within your workspace and be like, this was like, I don't have 158. I have like 172. And then it's impossible. Like the AI just decided that it was 158 for no apparent reason, and it's this black box thing that can be a bit frustrating because you have no control over like how it's gonna what it's gonna do about the data. So it all depends on the query of the user. If it like goes slightly beyond what you program your tools for, then it leaves that little bit of uncertainty that is like, well, we'll leave it to chance, I guess. And you don't, at this point, you don't even know. Could we create an entire workbench using AI assistance simply by providing a detailed description of what we want? I'm not so sure if it can create the entire workbench, but I think, you know what? That's a good question. let's see. In the meantime, it gives you the step for it. Thank you, Cal. So it's good that you
and there's another question from Michael. Do you know if you have to have the MCP endpoint public or this can be behind a firewall?
I'm assuming it's okay as long as you can have, because here when you create it, you have also the authorizations and stuff that you need to set up here. I will need to, if anyways, for now it's just in beta, it's not accessible for anyone. So
yeah,
let me check here.
I think it depends on your architecture type.
Yeah, because I think for now what I have here is like it's just available for everything. But even here, like my MCP, like this is not closed behind a firewall. It's just like on a hosted instance of FME Flow. So it's just accessible for anyone with this link can access this server here as long as they have the credentials. If it's gated behind a firewall, you might have to also add a few exceptions and stuff for the specific transactions of the MCP for this. I'm sure Safe, as they will release the official release of the MCP, because it's still going to be in beta in 2026.2, are going to add some more instructions on how to proceed with more different types of environments. Because for now, it's not even available to the public-ish because it's beta. So.
But I think if your FME server is exposed to the public, it will work. I guess it depends on your IT configuration, but anything is doable really with your IT. So I don't know if there's any more questions from anyone before we end this discussion today. Maybe not. I think we've given it a couple minutes. I'm going to share back my screen. Oops, not my screen. Nope. Sorry about that. All right. Oh, there is another question. Oh, Matthieu, can we use AI for migration? Ah, that's a good question.
As in you migrating from
with
like
the AI, yeah, telling it what to do.
migrating what things like the FME's ecosystem or like any migration of any system.
I think maybe is it migrating the workspaces or upgrading the FME flow? I think it might be migrating the workspaces to a different version.
Well, the AI can give you again the pointers of how to do it, but it's like depends on how broadly you're asking this question. Like, can we use the AI for migration? Yes, you can. You can ask it questions about like how to migrate your workspaces and how to make sure things are going to work properly, but it's not going to make like it's going to do it for you. It's the same as creating a whole workspace from scratch. It's going to give you the steps and how to do things properly, but it's not going to be able to do the whole thing for you. You can use it. You can ask it a question about it. You can specifically because you have this different like this context window for your questions. You can just select a few transformers and be like, okay, how would I do this to migrate them for another version for another stuff, and it would give you the pointers of how to proceed. But it's not going to do the migration for you. But yes, you can use it in some way.
Yeah, I think the AI assist is to be used for questions and maybe not doing the work actually for you. Maybe one day we'll get to that point, but not right now. All right, so I don't know if there's any additional questions. We really appreciate your time today. If you want to tell us how we did, maybe give us other subjects that you would like for us to cover in future webinars, don't hesitate to tell us. There's a question in the survey that will let us know what you would like. So please fill out the survey and tell us how we did today. And I'll give a couple minutes for people to do the QR code. Thank you everyone for being here and for attending. We really appreciate it. We appreciate seeing new names and current names that we know. So thank you so much. I'll switch to the next one. If you need any more information about Consortech, or if you have a project that you have in mind, need support in any way, shape, or form, don't hesitate to contact info@consortech.com. You can also visit our LinkedIn page and follow us on LinkedIn to see what we're going to be up to next, or where we're going to be, what events we're going to be attending. So we thank you so much. I hope you enjoyed this as much as we did. We look forward to seeing you in future events. Okay, I think we're done for today. All right. Thank you so much, everyone.
Thank you, everyone.